my essence of time has gone out the window. All right, so how do we approach this? Well, just a quick reminder, there's another way we could write this. You could write this as g of f of x. So remember that notation? You could see either or, and they mean the same thing. Well, what it means to me is if I have a function, f is on the inside, so I have to take whatever f is equal to, and I'm going to replace it into g. So whatever g is equal to now has a new input. So x plus 7 becomes the input into g. And if you wanted to show some work on this, you could. I like to think of it this way. So what I'm going to do is I'm going to take f of x, and I'm going to call it what it's equal to, x plus 7. And then I'm going to take g of x, and whatever g of x is equal to, wherever there's an x, I'm going to plug in x plus 7. That's my new input. Once you do that step, okay, that step is key, but once you do that step, everything else is just algebra. So what do? Well, we have to follow order of operations. I have to deal with the squared first. So I'm going to think of this as side work, and I might come over here and say, at some point, I've got to do x plus 7 times x plus 7. So you can FOIL, you can do the area model, however you want to do it. But when you distribute that, you get x squared plus 14x plus 49. And that's going to go in this spot right here. It's going to replace the x plus 7 squared. And then kind of at the same time, I'm going to distribute the negative 5. And make sure you're distributing that negative. That's another error that often happens. So double check. Did you put negative 35? And then we've got the minus 12. Well, now I have to simplify the next step, which is distributing the 2 to all those pieces. And then the last step is combine all your like terms. Let's see, I've got 28x minus 5x is 23x. And I've got a 98 minus 35, that's 63. All right, and then 63 minus 12. I think that's 51. So hopefully that gives you a little bit of feedback. I noticed on the Delta Math too that it was this concept that gave us more struggles. People did more problems because of it. So, all right, any questions on that? All right. So we know that we're going to have a test this Friday, and you can pretty much guarantee you're going to have a problem similar to something like this. So think of this as a little check off on your list of things either you need to study or you can say, yep, I mastered this. All right, so what we're going to do then today is we're going to actually jump back to Algebra 1 a little bit. And you may be familiar with this. It depends. It's been a couple of years maybe since you've done it. We're going to look at graphing square and cube root functions. Today we're going to be using Desmos to explore the graphs of the square and cube root functions. You may remember them from your past. Just a quick refresher, I'm not going to really go over a ton of this. I'll hint at one thing here today that will make sense later on. So we have a parent function for square root and cube roots. So the parent function is just the square root of x or the cube root of x. And these are their graphs. This is what each graph looks like. Well, today, you're going to be exploring with that and see how those graphs move left to right, up and down, or even grow or shrink or stretch. And one of the things I'm going to talk about is something called an A value. So the A value is like your starting term, and I just want to make this point right here. So here's my A value, and it's not written, it's always a 1. So let me show you just quick how this function looks. Well, how did they get this function? They took x equals 0 and they plugged it in. The square root of 0 is 0. Well, what if I go over 1? What about when x is 1? Well, if I plug in 1 for x, the square root of 1 is 1. And that first point kind of tells me my A value. So however high up I go, so think of this. What if this was a 2? What would the A value be? It would be up here at a 2, and my graph would get stretched out a little larger. You're going to see that, but it's that first point that really kind of tells us what that A value is. And that's not always super clear when you're doing the activity today. Again, I will review that, but I just wanted to make that aware right now. Well, what about the rest of these points? What if I go over to a next friendly number, like 4? 1, 2, 3, 4. Well, the square root of 4 is 2, and here's my parent function for the square root. Now, cube roots work the same way. The only difference is that they don't increase as fast. So if I go over 1, and if I plug in 1 in here, the cube root of 1 is 1. The next possible friendly cube root number would be 8. So I'd have to go all the way up here to 8. And then 8 would be up to 2. So you can see my graph is growing. However, cube roots also involve negative numbers. I can take the cube root of negative 1 and get 1, or I can be all the way up here at negative 8. The cube root at negative 8 is 2. My graph definitely appears different than what a square root function is. So your job is to explore that. Before we do that, I want to show you just a couple of things on Desmos, because we're going to be using Desmos. We haven't used it a lot, so please make sure that your eyes are up here right now. All right, a couple of things. See this lower corner here? It's a little keyboard. When that appears, you can click on it, and you can type in a whole bunch of different things. So I'm going to show you something that we've learned in the past, quadratics. What if I wanted to do y equals, and then I could pick a number like 2 x minus 4 squared plus 3. So notice it shifted my graph. And if you remember, this is the vertex form. I went over 4 up 3. Now that's written, but remember how this was always opposite of the way it looks on the inside? That's called your h value. Now one thing we're going to do is instead of having a 2, we're going to use a letter A. And instead of having a 4, we're going to use the letter H. H is for horizontal. And then we're going to have K for our vertical movement. Now, you're not really going to have to type in these sliders, but eventually you will when we do this Desmos project, so we might as well show you it now. How would I get a slider? Well, by just typing variables A, H, and K. See how it says add a slider? If I click all, now it gives me a slider that I actually can move, so I can see just the effects of A has on this parabola. So part of what you're going to have to do is you don't change anything with the equation that's written. You just grab this dot, and you can change it, and look at what happens as A gets really big. This graph gets super narrow. Well, what happens if A is just less than 1? See how it's getting wider? And those are things that we experienced with quadratics in chapter 4. Well, what if we had a negative out there? what did the negative do? What did we call that mathematically? The graph goes from opening up to opening down. It's a reflection. Because remember, reflection, it reflects over a special axis. In this case, it reflects over a line y equals 1. Anyways, so if it's a negative a value, remember how to open down? You're going to experience very similar pieces today when we look at square and cube roots. So then what if I decide just to play with the h value? What does h do? Well, h moves items left and right, but you have to be very careful with h. Notice how the equation says x minus h? If I plugged in negative 3.5 here, it would say x minus negative 3.5, and a subtraction of a negative actually would say plus when the equation was written out. So that's the one thing I'll warn you about today is your h value is opposite when it's written in the equation than the way it appears here. And then your k value, you can kind of guess very quickly what the k value does. So that's your job at first, is just to play around with sliders, and then we might have you write your own equation. So if I ask you to write an equation that has a square cube root, you're going to pull up that keyboard. Square roots are pretty friendly, so you type in y equals the square root of x, and maybe we have a minus 4. But to get out of the square root, I have to press the over button to add anything after that. So let's say I wanted to have this bump up 3 units. See how the plus 3 is outside of that root? Or what if I wanted to put a number in front to see what happens when I put a 3 there? Oh, it grew. And then you can move this around. You can zoom out if you need to see more. You can zoom in. But what if I want to get a cube root? Because this is a square root. How do I get the cube root? So, see the function button right here? You're going to go to function, and you're going to have a bunch of options. Miscellaneous is one of them. And right in the middle, it says nth root. Now, it might look different on your computer because imaging, it adjusts to the screen size. But if I click that, notice it starts blinking up there. If I put a 3, that's going to give me the cube root. Then I have to put x, and it's always a good reminder to start off with y equals. Because that's the relationship. X and y are related. But, see this graph? That's my parent function. Okay? And if I put a number in front, what if I put a negative 1? Why did that? Oh, it just reflected. It did it before I saw it. So see how it flipped its sign? If I get rid of the negative. Anyways, you guys get to play around with that. But I can add more values in here. So what if I say add 2? And then I go outside of that, and I say minus 3. Okay, what happens? My graph moved on me. How did it move is your job to explore today. All right. Trying to think of any other issues that came up that kids had. Oh, let's say that for some reason you can't get this to come up, and you want to type in a square root. There's a shorthand. If you do S, and it's written in the Desmos activity, so you don't have to memorize this. But SQR, and when I hit T, it turns into the square root. So SQRT is the shorthand for square root. But what about an nth root? Then I'd have to do n, and then type in root. And as soon as I hit T here, you can see, assuming I spelled that right. Does I have an extra L in there? I can't see it from here. I think that's, yes. I need an H right there. So nth root will get me right back to the same spot. So if you can't find the nth root button in your functions bar in the miscellaneous, you could type in nth root, and that will give you what you need. So here's what you guys are going to do. You're my 6th hour. You're going to log in to go to student.desmos.com. And then when you get there, they'll have a classroom code that you'll just have to join. Some of you are already in this from last try or so. And then the very first activity on there should either say something like square roots, graphing square roots and cube roots. It might even say copy of, because I copied that from my other class. So you can just work through that, and then I'll be available for questions. If you have any questions via Zoom, throw it in the chat and I'll monitor that. Questions in the room, raise your hand. I'll come around and help you out. And our goal is to get as far as we can through this, knowing that we probably won't finish it in class this afternoon. And then I can monitor. I get to see all the work, so keep in mind that I'll know how far you are at any given moment. And I am double checking that everybody's up to date. You do not need the calculator part on Desmos. All you need to do is go to the student.desmos.com and type this code in, and then you'll get to a title that says copy of graphing square and cube root functions, and then that's just you use that activity. So you don't need the calculator on Desmos. It walks you through it. So there's a question on the Zoom chat here. It says, what does it mean when they tell you to switch the x, y values in the table? So for that slide, you have your first table, and you're supposed to plug in -2 into x squared. So -2 squared would be +4. So that'll be the first table that's in green, and then you take those 2 points for the next table in red, and you just switch. So instead of -2, 4, it should say 4, -2. You're just literally switching where the x and y values are, and then create a new table, and that will show you the inverse function, which is actually leading us to the square root function. So I'll share, if anybody wants to, I'm going to share how number 9 would work. There's a question on how to do number 9. So if you're on slide 9 and you want to watch, this is how I would set it up. So our goal is to type an equation in so our original blue parent function looks like the red function. And the tricky spot with this is the a value. I think that's the hardest part. So actually what I might do, you guys are going to hate this. I'm going to pause the activity. So everybody just give me a minute to look up here at the screen. Those of you at home on Zoom, it's paused, so you can't resume it until I hit play again. But what I have to do for slide 9 is I have to type this equation in. So if I hit y, there's a little button here, I could use that. I could do y equals, I know it's a square root function. And then how far did it move? Well, I moved 4 units to the left. So I'm going to have x plus 4. That's always the opposite movement. And then I went down 1, 2. So I'm going to have to go over to the side, press over, and then down 2. Now, that's not going to give me everything. That's going to take this blue function and just move it. But I didn't get the stretch. And that's the part I wanted to show you is how do we get the a value? Well, let's look at this. If I go over 1, up 1, that means my first point has a vertical rise of 1. Well, let's check that for this point. If I go over 1, up 1, 2, 3, that's a vertical stretch of 3 units. So my a value will be 3. And then that's all you need to do is write out how did that work. If you want to, if you're not sure, you could cut this. Maybe you could copy it. Okay, maybe not. Control C. And then I could go back to like slide 8. And I could try typing that in for a different function. And you can kind of see how that is exactly what the other graph looked like. So you can always go back to slide and play around with that. But I wanted to show you the a value on that because that's the hardest part, I think, is just figuring out from a graph, how do I find the a value? And it's just from that dot, how far did I go up, being 1 unit away. Okay, I will resume this. You should be able to start from where you were at. Somebody asked if I could quickly go over the a value again, so I will. How do we find the a? Well, on the original parent function, if you look at being 1 unit away here, so if I go over 1, up 1, that's an a value of up 1. For the a value on the red function, I would go over 1 and count how far up would I get to that next point. So here I'd go over 1, up 1, 2, 3. And that's how I knew I had a value of 3. If it was reflected, if it opened downward, then it would be a negative. So a really good question just came up. I'll address it here. It said when we find that a value of going over 1 and up however far, that's just kind of a quick way to check the a value. It's not like slope. So the a value isn't rise over run for every point on the graph. It's only to determine the very first point. And then everything else after that is going to change because we're squaring, cubing, square root or cube root. So that's a phenomenal question there, and I thank you for asking that. So there are 2 questions here I might quick address. It says for number 12, the question is asking us if the points match the first graph in red, but the second graph is the one in red. So number 12 says go back to question 4. I believe, let's see. Oh, sorry, no, I misread that. Go back to question 11. They should be, if yours is both in red, that might be a error on yours. If I look at mine, so here's slide 12. 12 tells us to go back a previous slide. So if I go here, I got a table in green. That's going to produce a green function. The table in... So what should happen, I think what might happen is your points here for your red one might not be accurate for the function itself. So if you didn't get your points in red to match up with this red line right here, then go back and check. Remember, you're doing the cube function here, so x to the third power instead of x squared, or make sure you're raising it to the third power. So I guess that'd be my first comment, is make sure that your points in your table match both the green graph and the red graph. Okay. And then the other question was about slide 16. So slide 16, it says, what is the equation of transformed cube function graphed below in red? So the blue one is the parent function, and we do that just so you can identify where the start was. And then you have to say, okay, well, what is now the cube root function? So you have to type the cube root function in. So I would do something like this. And we know it's a cube root function. And then I have to determine the a value. And I think that's the hardest. The a value is going from this middle point and going over 1, down 1, 2. So I know that the a value is a -2. And then I have to think about, how did it move? Well, it moved 1 to the left, and it went up 1, 2, 3. So then you would put in the values for x that made it move to the left 1 and up 3. And if you want, you could even put parentheses, something like this, and then pick a number here, whatever you think it is, and so on. So I'm not sure if that answered both your questions, but I can. If you need, I can answer more of them.